everyone! Today I'll be explaining the theory behind N.M.T. Imagine that we have a glass of purified water and a small amount of liquid is dropped in. This liquid has a very high concentration of ions or molecules. Here we'll use calcium ions as an example. So the liquid has a very high concentration of calcium ions. Soon a calcium ion gradient will be formed. But how do we know this? First, we need to build a sensor that can detect calcium ions. The key here is to use calcium selective liquid ion exchanger. In short, we call this LIXs, and it is able to give us corresponding voltage readings. Next, we will use the calcium sensor to measure the concentration of calcium at two different points. If these 2 points have a different concentration, we know there is a gradient. After establishing that there is a gradient, we can find the concentration difference between the 2 points. This concentration difference is plugged into the equation for Fick's law of diffusion, along with the distance between the 2 points. When we plug the calcium diffusion coefficient into the formula, we get something very useful for biologists. The result tells us how many moles of calcium ions pass through a square centimeter area in a single second. We call this information the flux data. Now that you know how N.M.T detects fluxes, let's take a look at a real-world example of how N.M.T is applied into biological research. In plants, calcium ions are believed to be constantly absorbed into the root hairs, which is necessary for their growth. With the application of N.M.T, not only can we confirm the influx of calcium ions, but we can also tell exactly how big the fluxes are. In this case, we found the influx of calcium was greater on the tip of root hairs than in other areas measured. As of today, the LIXs showing on the screen are available to make different ion sensors. In addition to ionic sensors such as the proton sensor and the cadmium sensor, N.M.T can also work with molecular sensors. The available molecular sensors are oxygen, hydrogen peroxide, and IAA. New LIXs for ions and new molecular sensors are being developed as I speak. So, if you have a special interest in other specific ions or molecules, please contact us. We are more than happy to work with you to get these new sensors available to you and the research community worldwide. Please subscribe now or visit our website to keep up with our latest developments. Thank you for watching. See you later.